Good morning. Hope you can hear me and you can see my screen. Good
Good morning,
morning.
sir. We
Good
can
morning,
see.
sir. Yes, can see.
Okay. Right. So last week we discussed about the networking devices. Right. So under that we discussed about various networking devices like network card, hub, switch, router, and modem. So how they work within the network, right? So first we talk about the network card, then hub, then switch, router, right? So then we came to the modem and router. Then that's the place where we stopped. Then we will move to the next part, home networks, right? So these days, every and each houses have a small kind of networks because especially after the 2020 COVID pandemic, so these digital device requirements were highly advanced, right? Before that, yes, we had some devices like mobile phones and all the things. But after 2020, with the COVID pandemic situation, so before that, sometimes the whole house having one smartphone for one person, maybe the father of or mother of the house, right? So both have had the mobile phones, but the kids didn't have any devices. But after 2020, with the pandemic situation, right? So all the things were started doing online. Even this before 2020, have we ever heard about this Zoom facility? That we have never. Zoom was there. Even that time, Zoom was there. But in Sri Lankan situation, very rarely we were using, right? But with the pandemic situation, the demand for this online working was highly increased, right? Work from home, the so online teaching, all those things came to the discussion. Therefore, use of digital devices also advanced and increased. Even we had to give, whether we like or not, we had to give the digital devices even for a grade 1 student. Because at that time, many of the education done as online, right? Then when the usage of digital devices increase, so this internet usage also increase. Then we need several devices to connect with the internet, right? So then we had to create a small kind of network even at the our house. Whether uh, we know with our awareness or without our awareness, already we have created a small network at our home because we are connecting different digital devices at home, connecting to the internet. Therefore, maybe without our interfering, we have created a small network. So, these home networks can be divided into two parts. One is wired network, or other one is wireless network, right? Wired network or wireless network. So, in a wired network environment, so to connect internet, so we need two things, right? So we discussed this. One is modem. Modem is the device we connect with the internet, right? So then to connect other devices, we need another devices, that is router, right? Router and a modem is a must part even for a home network. So all the devices at home, right? All the devices at home connect to this router. Then router is connected to the modem, right? Modem is connected to the internet. So all these devices connecting with the router through a wire, UTP wire, right? So the wires should go all around the all around the house, right? So all the parts of the house. Normally, this kind of wired network is not visible in home because we are not cabling here and there. So in the on our walls, the at like in our office, right? So we are not cabling this cable and all those things. We are not putting in our home, right? But if you need, you can do, right? But for the then from each devices, you have to have a wire to the router. Normally, we are not doing. Suppose it's a story building, two stairs, right? So if you want to internet for the downstairs, upstairs, right? So you have to have a wires from the this router. So normally it is not happening. Then the wireless signal. This is the most popular. This is the one practically we are having at our home. Right? This is the one practically we are having at our home. Right? So there is a modem, there is a router. This sometimes modem and router is coming together as one device. Right? Modem and we cannot have two devices. Right? So it is coming as one device. So it depends how the service provider is working, right? So anyway, we need a modem and router. So then this router, from this router, all these devices are connecting. All the devices are connecting to the router in wireless modem, wireless medium, right? Wireless medium. It may be a laptop, it may be a smartphone, it may be a desktop computer. Yes, desktop computer having a wireless antenna in desktop, so they can connect wireless as wireless medium. Anything, right? So no wires are in between the router and the device. Everything as wireless. So this is how normally our home is working, right? So even your home, so you may have seen that. So your mobile, all the people, all the mobile phones is connecting to the your service provider, internet service provider. Your laptops connecting. What do you mean? This tablets, it is again connecting, right? So what are the advantages? What are the advantages of having this? Suppose outsider come to the home, right? So your relation or friend or come to the home, and that person also wants to connect to the internet for some specific work, right? So if you are home, if you are having a wired network at your home, so it is very difficult to connect with the internet because you have to give a specific IP address for that person. So many things you have to do. But uh, when the person coming to the home, if you are having a wireless network, so just you want to, but you have to trust that person, right? You just need to give the password of your network, or you can type the password in. If you don't know, if you didn't want to give the password to that person, whether he's relation or friend, you just can type the password and make the connection to that person. That can be done very easily. Wireless networks, right? Then mobile hotspot. So you all know this, right? With these smart devices, so the technology has been very advanced, right? So suppose you don't have any kind of wired or wireless network at home, so but still you need to connect with the internet. So what you can do and what others can do, so you can connect the internet even through your SIM card, right? So you are through SIM card, you can connect to the network, is internet. So what you can do is there is a special feature in this modern smartphone. So you can switch on your hotspot, right? You can switch on your hotspot. So when you switch on your hotspot, so your mobile phone work as the router and the modem. Right, then your mobile phone working as the router and the modem. So others can connect with your mobile phone. You they can use internet through your mobile. But for that, the person who is enabling the hotspot should have good high amount of data, because others are going to use your data, right? If you have very limited data, so it will be finish within very short period of time. But if you have suppose unlimited package or something, right? So you can switch on the hotspots and you can uh, provide the access to the others. So not for many, right? So few people, maybe three, four people can access, but not like 50 people, 100 people. So it will not allow. Even then, the speed will be very slow. So, mobile hotspots. Right. That's all about the devices. Now, we will move to the physical topology of networks. Physical topologies of networks. The physical topology of the network explains how the network is physically arranged. So, topology means how this network, how a particular network is physically arranged. That is what we meant by the physical topology. In the other words, physical topology is the geometric representation of all links and nodes in a network. How these network nodes have geographically connected, not the size, not the number of computers available, right? That is not there. Not the number of computers, not the size of the computers. So how the mainly focusing on how these things are geographically interconnected. So there are many. As an example, right, suppose there are two computers. There are only two computers which is connecting each other. One from the Jaffna, the other from the Matra. So too long, right? So far away, too far away. One is from Jaffna, one is from only two computers. So that is what we are having. Sorry. So I will come to that point. So there are mainly several types of networks, right? There are mainly several types of networks. Bus topology, star topology, ring topology, tree topology, mesh topology, and hybrid topology. Let's talk one by one. bus topology. This is not the bus what we are talking about, right? So this is not the bus which is moving on the roads, passenger traveling. These are not bus. So here the bus mean a hard cable. Bus mean a hard cable, right? So there is a very hard cable in this topology. That is the main part of this topology. So backbone, we call it as a backbone. Right? It's a very rigid, tough cable. All the devices in the network is connecting to this bus or the backbone cable. All the devices, right? All the devices in the network connecting to this bus, this backbone. Data packets are moving through this bus. Data packets travel to all the devices in the network and then identified by the relevant computer or device which the information is needed. So mainly coaxial cables are used to create this bus, right? Mainly coaxial cables are used to create this bus. Normally the speed is very low limit, right? So data transfer speed is about 10 Mbps. And remember, so you cannot connect large number of devices to this kind of network. Maybe maximum number, maybe 10 devices. For a small kind of office or home, this is perfectly okay. But if you have many computers, like 50 computers, 100 computers in your network, so this is not suitable. So this is how this network is working, right? So this is the backbone cable. So when one message is coming, it's going to the all the computers, and finally it will identified by the relevant computer that information is needed. Right. So let's talk about the advantages and disadvantages. Advantages are the bus network is easy to set up because of the speed and simplicity of network construction. The cable length required for this topology is minimal compared to the other. So the minimal number of cables you can have. But other topologies, when we discuss it, you can see it is needed long distance of cables. Installation cost is therefore very low. So failure of one device will have no effect on the other. If one computer is not working, still other computers are working. Disadvantages. So there's a limit for the central cable and the number of devices that can be connected. So this central cable backbone, the bus, you cannot have very long distance. There's a maximum length you can have this bus. Right. So also there's a limit for a number of devices you can connect to the this kind of network. So I told you that maybe maximum 10 numbers. Even connecting these devices is not very much easy. Right. So at the beginning you have to plan how many computers you are going to connect and what are the places. Time to time you cannot one is removed and you cannot add another one in another place. So that is much difficult. Right? So all the function of this network based on the bus cable, right? Bus. If this bus cable is damaged, the entire network is not working. Suppose the mouse biting or something, right? So this bus main cable was damaged. Then the entire network is not working. Adding new devices to the network is difficult. The bus network is often used in small networks, right? Not for a very large networks. Then the next topology is star topology, right? Star topology. So star topology, it's like a star, right? So there is a middle device and all the other connecting devices are connecting to this middle device. This in middle there is a hub or switch or maybe router, right? All the devices are connecting to that one. There is no central cable. So cables are coming from uh, each devices, but not like earlier one through a single cable. The most popular network topology is the star topology. A star type network is formed by connecting to the devices in the network to a central controller. Hubs or switches are mainly used as a centralized control of starter panels. Mainly twisted pair cables or fiber optic cables are used. Data speed is very high, approximately 100 Mbps. So the data speed compared to the bus in this network is very high. Therefore, this is the most popular network when we are creating network topologies in different places, right? So this is how the star topology works, right? The switch is taking the information to each computer, right? This is switch or hub. So these are the devices. So let's talk about the advantages of star topology. Network management is much easier due to the need for a separate cables to each node and centralized hub. So we don't need to manage the one cable, right? So like bus. So there is a cable from each devices to the hub. So very easily we can add new devices or we can remove the existing devices. It will not affect to the other parts or network. When one device is removed, right? So still other devices are working. If you need to add another devices, if you have the extra ports in your hub, so still very easily you can have these new devices. So you don't need to stop the network or you don't need to stop all the other workstation. Still you can work and add the new device. Failure of one devices does not affect the other network devices, right? So if one is not working, still the other stations are working. Since the cable failure only affects a single user, it is easy to diagnose and fix networks. So identifying and diagnosing and fixing network errors is much easier in this kind of network, right? So we can identify where the if one computer is not working, we still the others are working. So we need to check the computer which is not working and its cabling, not the entire network cabling. Because if the others are working, the problem is either with this device, the computer, or the wire coming from that computer to the network. Sorry, that computer to the hub. That is the only part we need to check. But if that is if the fault is with the bus, so we have to check entire bus, especially the bus cable, because we cannot identify where actually the problem is. There is no interruption to the network when connecting or removing devices, so the network can be easily expanded. So you can increase the number very easily. So the speed is very high for data transfer. That is advantages. Disadvantages. So though there is a not though there is no centralized cable like bus, but there is a centralized device, switch or hub. If this centralized device the switch or hub is not working or gives some errors, again, the entire network is not going to work, right? If this centralized device is not working, the entire network is not going to work. The efficiency of the network and the number of devices that can be added to the network depends on the capacity of the central controller. Yes, this switch, right? So it has each switch has the number of it has specified the number of devices which can be added. Sometimes it has 8 ports, then only 8 computers can add. Sometimes it says 16 or 32, 64, 128, 256. Right, so it goes like that. So that number tell you that how many devices you can connect. If you are having a 8-port switch and trying to fix 20 computers, you won't be able, right? So if when you are planning this network, if you have a plan to expand in future, it is better to put a uh, switch which is having more ports. At the moment, you may are connecting 5 computers, but in near future, you are going to connect another 20. That becomes 25 computers. Then you should have a switch which can allocate for that. Otherwise, at that, if you think about the cost, so you are wasting money because you are going to have a 8-port switch right now, then within 1 year's time, so you need to remove that 8-port switch and need to have a 32 port or 64 port switch again. But at once, if you have put 32 switch in your network, so you want to spend more money in future. This requires more cabling, but in this networking, so you need more cabling, little bit cost is high, right? So normally routers, switches are expensive based on their uh, number of ports and the technology. So you need to have extra cost for these things. Next one is ring topology, right? Next one is ring topology. So in this network, the devices have been connecting like a ring. These things has been connecting like a ring. No central cable or no central device. No central cable or no central devices. So all these devices have been connected as a ring, and there is something called token. Right, it's always moving throughout this network. Right? When one device is want to send a message, they will take this token, right? Then they will send the message with this token. So token is going here, looking whether the address given to this computer. Token is like the postman, right? So going to this computer is checking whether the address is given to this computer. No. Then he is moving to this one. Again checking the address is matching. No. Going to this. No. Going to this. Ah, yes. This is the address which this message is sent. So he is handing over the message here and token is again moving and moving. If this computer wants to send a message, then he take the token and send his message with the token. So that token is found in the relevant computer. So this is how this computer is work. This network is working. Computers are located in a ring connected to each other by cables. Any data or information travels in only one direction in this network, either clockwise or anti-clockwise. Here, a token constantly passes through the ring, and this token can transmit data to the computer that owns at that time. The data packet transmitted in this way passes through every computer connected to the network. At the time, after the data packet reaches the computer to which the relevant data packet is directed, that computer receives it. Otherwise, when the data packet reaches another computer, the data packet is given more power and directed to the next computer. Mainly twisted pair cables are and fiber optic cables. So mainly to connect these devices each other, it is using either twisted pair cables or fiber optic. Normally fiber optic are not using because those are very expensive. Normally twisted pair cables, right? So this is how this ring topology is working. So let's see advantages and the disadvantages of the ring topology. Advantages are data flows in a circular direction which reduces the chances of packet collisions, right? So no accidents are appearing when the data is transferred. A network service not required to control data flow, right? So no central devices is here. Ring network easy to maintain as compared to the bus network. The network can handle a large number of devices and the addition of these devices has very little impact on network efficiency. Less expensive compared to the mesh, tree and hybrid panels. The failure of one computer in the network causes, so as every and each computers are interconnected, so one failure of one computer affected to the whole, right? That is a disadvantage. So, so we can remove this part here, right? So it is not needed here. So this is controversial, right? Adding and removing any node in a network is difficult, right? So when you try to adding or removing any network device, right? So it affect to entire network because you need to suppose you need to remove this one. So you have when this one is removed, so entire network is not working. So when you adding one new devices or removing existing one, it affect to the entire network. Diagnosing and troubleshooting network errors is difficult. In order to computers to communicate with each other, all the computers must be turned on, right? Next one is tree topology. Tree topology. It's like a tree, right? It's like a tree. Here, this is something you need to identify carefully. This is not a one network. All those three, it's a one network. This is not a this tree topology is not one network. It's a connection of networks. It's a combination of networks. Right? It's a combination of networks. So you can see here. This is one network. This is another network. This is another network. This is separate network. All these networks are interconnected like a tree. Right? So this is the stem and these are branches like a tree. That is why it is called as the tree network, tree topology. Combining several star topologies into a bus topology is known as a uh, vegetative plan. So this is a star topology. isn't it? So central devices and the computers has been connected. This is another star topology. Central device and branches. Central device and the devices. So all these star topologies are interconnected using a bus backbone cable, like the bus topology. Here two topologies are using. One is star topology and the bus topology. The nodes of a bus patch network are replaced by a complete star patch network, right? Here all computers are interconnected in a hierarchical manner. Expanding an existing network is easy. So if you want to add another network, very easily you can add here. So a network is somewhere here and you can have a cable to this bus cable. So this is tree topology. So let's see advantages and disadvantages. Advantages are if any node falls, other branch networks are not affected. So if any particular network is not working, so no harm to other networks. Still other networks part are working. Maintenance and fault detection is much easier. Since leaf nodes can add more nodes in the hierarchical chain, it is easy to expand the network. Very easily you can expand the network, right? So easily you can increase the number of devices in each network. Disadvantages, configuring is much difficult because you have large number of computers there. Not 10 numbers, not 20 numbers. You can have 100, 200, 500 number of. So configuring these networks is much difficult, much complicated. So need relatively large amounts of cables, right? Because this connect several star topologies. Tree topology mainly depends on the main bus. So here again a bus cable, main cable is there. If something happens to this bus main cable, the entire all the networks is not going to work. That is a big disadvantage. As there's a one bus cable, if something happens to the bus cable, the entire network is not going to work. Mesh topology. Mesh, right? So what is happening in mesh topology? Each computer is connecting with the each devices in the network. Look at this computer. It is connecting this one, connecting with this one, connecting with this one, connecting with this one, connecting with this one. Each computer, if you take this one, same way. So each computer connecting the other computers very easily. So this has several paths to reach this computer, right? So this creates several paths to reach for a one particular computer. Suppose this computer wants to send a message to this computer, he can send this way, or he can send this way, or he can send this way, this way. So several paths has been created. If this is broken, still it has several ways to send the message here. Thus, each computer in a mesh topology network is connected to each every other computer, creating a point-to-point connection between each device in the network. So it can be seen the establishing connection in this type of mesh topology is very difficult and requires more wiring. So establishing this kind of network is very complicated, right? So and you need long distance of wires. If one cable fails, the data always has an alternative route to its destination. So this is if this is damaged, still several ways to reach here. The switch acts as a central point of communication. Nor does it contain any central computer. So no central devices is here. So the internet is the prominent example of this. Because in the internet, all the devices connected with the internet are interconnected. If you want to send a message to a particular computer, you can find many ways through the internet, not in one direction, right? Mainly, this kind of networks are very popular in wireless network. In a wired network, this is very difficult, right? So wireless networks, so very popular. Mesh topology, right? So advantages in mesh topology, these network devices have multiple connection. So if one path is blocked, other path can be used for data communication. If one path is damaged, blocked, something happens. So there are several ways to send the message to the required destination. There are dedicated links for each computer, so there's no traffic cognition, right? So if one path is traffic, heavy traffic in one path, so it's find another way to send the message. This network ensure that the data security as such messages travel through the only be designated path. Disadvantages, the installation cost is very high. So this is really high. So you need many wires, right? So many ports. Installation compared complicated as each node is connected to it. So very complicated configuration is needed here, right? So very difficult to configure. The final one is the hybrid topology. Hybrid topology. So in the tree topology, you connected several star topologies, right? Through a bus cable. But in the hybrid topology, you connected different kind of topologies as one network. So this is ring topology. This is mesh topology. This is bus topology. All these different types of uh, networks are interconnected. This kind of topology we call as the hybrid topology. So one topology, one ring topology is there, one mesh topology is there, and one bus topology is there. The main characteristic of a hybrid network is that several networks built on a different topologies are connected. Several different type of topologies are interconnected. Hybrid mesh networks include bus mesh, ring, star, and tree. The combination of hybrid depends on the need of the organization. So the organization need to decide whether we need this kind of complicated, maybe sometimes depend on the requirement you may need, right? So advantages, if a fault occurs in any part of the network, it does not affect the operation of the other. If one network is fail, still the other parts will work. The size of the network can be easily expanded by adding new devices without affecting to the performance of the existing network. This topology is very flexible and it can be designed according to the needs of the organization. Hybrid networks are very effective because they can be designed so that the strength of the network is maximized and weaknesses of the network is minimized. Disadvantages, the main drawback of the hybrid network is that it is very difficult to design and structure of the, so as this is very complicated, right? As this is very complicated, it is very difficult to configure, right? So different type of networks, right? So many cables, so many devices. As there are different kind of networks, so you need the configuration different for each network. So this is very complicated and very difficult. So the hubs needed for these kind of hub or switches needed for this kind of hybrid networks are very expensive. Right, so those hubs or switches needed very special capabilities connecting these different kind of uh, networks. So as these switches hubs are expensive, so you need more money. Infrastructure costs are very high as the hybrid network requires a large number of cables, network devices, etc. So this kind of network is definitely very costly. Okay, as usual, that's a video I found from the internet. So I will play for this for you. So it will explain everything again, and so you will realize what I explained up to now. If the sound is not hearing to you, please let me know.
What are network topologies? So that's what we're going to talk about in this video. Now, a topology is the layout of how a network communicates with different devices. And there are a couple of different categories of topologies. There's wired and wireless. So we're first going to talk about the most common wired topologies. And the most common wired topology that's used is the star topology. Now, in a star topology, all computers are connected to a central wiring point, such as a hub or a switch. All data on a star network passes through this central point before continuing to its destination. Now, one of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. Another type of topology is called ring. The ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. Now, this kind of topology is very old and is rarely used today. Now, the advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And the next one is the bus topology. The bus topology is very old technology and, like the ring topology, it's not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is also fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. So if a computer is removed or if the terminators are loose or missing, then the cable would be open and then data would bounce back. And this bounce is known as signal reflection. And if this happens, data flow would be disrupted. And there is also the mesh topology. Now, in a mesh topology, each computer on the network is connected to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. Now, the advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other. However, because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks like the Internet. In fact, the Internet is a good example of a mesh topology, because the Internet is made up of numerous routers all over the world that are connected to each other to route data to their intended destination. So even if a few routers go down, the data will get rerouted using a different path to ultimately reach their destination. So the Internet is very redundant because it's using a mesh topology. So now we're going to talk about wireless topologies. So let's start with the infrastructure wireless topology. Now this topology uses a combination of wired and wireless devices. Now this is very similar to a star topology, where you have wired devices such as these computers here physically connected to a switch. And you also have a wireless access point that's also connected by a cable to the same switch. The wireless access point is here so that wireless devices such as laptops, tablets, cell phones, etc. can connect wirelessly to the network. So the wireless access point acts like a bridge between the wireless network and the wired network. Now the infrastructure topology is not limited to a single wireless access point. In fact, you can have multiple wireless access points if you want. It just depends on the needs of the network. And the next wireless topology is ad hoc. Ad hoc is a very simple wireless topology, and it's simple because it doesn't rely on any infrastructure such as cables, routers, servers, or wireless access points. All the devices in an ad hoc network wirelessly connect to other devices in a simple peer-to-peer network. They directly connect to each other without using a centralized device, such as a Wi-Fi router or access point. And because they directly access each other without a server or router in between, each device is responsible for its own security and permissions. Ad hocs are useful for setting up a quick wireless network on the fly where devices can share data without the need of an existing wireless network. And the last wireless topology is called a wireless mesh. Wireless mesh topologies are similar to wired mesh topologies, where devices are interconnected with each other, but with the exception that they are wirelessly interconnected. So for example, let's say you wanted to deploy multiple wireless access points all throughout a building so that wireless devices that are in different areas are able to access the internet. So normally you would have a modem that brings in the internet to the building. And then you would also have a switch that's connected to the modem. And then you would connect each wireless access point with a cable to the switch. So by doing it this way, this requires extra cabling, and it would also require extra time running the cables through the building. So this is more expensive and more time consuming. Now a wireless mesh topology would be similar to this setup, but without the need of these extra cables. In a wireless mesh, each wireless access point will talk to other wireless access points to create a seamless internet connection for wireless devices to connect to. So if this laptop over here wanted to access the internet, it would connect to the nearest wireless access point, and then this access point would relay the connection to the next access point, and then to the next one, and then eventually find its way back to the modem. So no matter which access point that you're connected to, you will still have internet access because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the other access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points.
Okay, so hope so you now have a good understanding about how these topologies are working and how these topologies are created. Right. Then we will move to the types of network we can see. Now you should, this is a place, this is a thing that most of the students are mix up network types and network topologies, right? Network topologies means how the devices are interconnected physically, not geographically, how they have interconnected physical. Now, network style based on how these computers have geographically interconnected, not how they have interconnected, whether it is a star topology or whether it is a mesh topology. Right? So, and also it does not affect with the number of computers interconnected. As an example, so normally uh, network types we can have four mainly. There are maybe other, but mainly four. LAN, local area network. CAN, campus area network. MAN, metropolitan area network. And finally, WAN, wide area network. The classification of computer network types is based solely on geographical location. Remember that geographical location, that is very important. It has nothing to do with the number of computers on. As an example, right? So as an example, suppose there are two computers connecting with one from Jaffna, one from Matara, long distance, right? So two computers connecting each other. So what do you think? Is it a LAN computer or WAN computer? Remember, though there are two computers interconnecting in that network, it's a too long. Distance is very high, very long. Therefore, we consider that as a LAN. Sorry, WAN, wide area network. Too far away, too far away. It's a WAN network. Meanwhile, there is a network with 500 computers, right? Within one building, right? 500 computers with within one building. It maybe have several stairs, right? So first floor, several floors, right? First floor, maybe suppose there are 10th floors. So among these different floors, there are altogether 500 computers, but within one geographical location, one building. That kind of thing, though it has many number of computers, 500, right? We call it as the LAN. So basically, you should be able to understand that this differentiate basically depends on the geographical location, not how they have interconnected or not the number of computers. Right. LAN, local area network. As I explained already, so local area networks, a local area network is a type of network located within a single building or very small geographical area of an office, home, educational institution, or other organization. Basically, we are considering as a LAN within one building, within one geographical location. So within your home, within your office, one particular building, all the computers are internet connected. So that is one LAN, right? This type of network can be very small network consisting only two computers and a printer, or a network consisting of large number of computers, server computer and printers. So it can be very limited number of computers. Okay, so it is a LAN. So still you can have many computers, 100 computers, 500 computers, printers, servers, everything, but still it is in one particular building, within one particular building. Still it is again a LAN. This has no connection with the number of computers connected, number of devices connected. A computer network connects computers through communication devices such as coaxial cables, uh, routers, and switches. This type of networks are often created to share resources between computers or network stations. Shared resources can be hardware, software, anything. Right? So this kind of thing. All the devices are interconnected within one particular building, LAN. The second one is CAN, Campus Area Network. So normally, this is something like this. A campus area network is a group of interconnected local area networks within a limited geographical area, such as school, universities, and military bases. Suppose take the universities. Okay, as an example, take uh, the University of Colombo. Right? So, University of Colombo, suppose this is the University of Colombo, this image. Right? So, suppose this is library building. This is library. Within library building, it has a one separate LAN, right? Suppose this is college house, administration building. It has a separate. It has a separate LAN. Suppose this is another faculty. Suppose this is a management faculty or something, right? Or suppose this is the Nilis building. So this has a separate uh, LAN. So each building has separate LAN, and these LANs are interconnected. So these buildings are very close by, not so far away, not like Mathura and Jaffna. So the each buildings can see each other, but separately established, very close by. So this kind of, if these LANs, this LAN 1, 2, 3 are interconnected, that kind of network we call as a campus area network, right? CAN. This network is specially designed and used for education in institutions like schools, colleges, and universities. Depending on the geographical area covered by the university, the network is spread across different buildings and areas of the university. In a university, CAN is established by connecting the networks of academic department, administrative department, library, examination department, account department, etc. Connections are made by connecting LANs through routers and switches. A campus area network is larger than the LAN but smaller than a metropolitan area network, the one we are going to talk next. Then next one is MAN, Metropolitan Area Network. So this kind of network like this, suppose a organization is having branches in different areas of a city, not the all around the country, within one city. Suppose we have in Colombo, Colombo 1, Colombo 2, Colombo 3, Colombo 4, like up to Colombo 15, right? A particular organization is having branches or office in each area of Colombo 1 to 15. Right? Colombo 1 is the Fort, Colombo 2 is the Peta, Colombo 3 is the Colpiti, Colombo 4 Bamblapitia, fifth is where? Narayanpeta, I suppose. Right? Colombo 6 is somewhere, Vellavatta, Colombo 7, Kurunduvatta, right? Likewise, Colombo 50. So all these 15 places is having their own offices, right? So it's a limited area within the city area. Right? It's not like very close by the can, but still it is close by within one city. Within one city. So this kind of network we called as the MAN, Metropolitan Area Network. A metropolitan area network is a collection of several local networks LAN. So this is one LAN in Colombo 1. This is the second LAN in Colombo 2. This is the another LAN in the Colombo 5. Likewise. So all these these LANs are interconnected, creating a MAN. These networks are larger than the local area networks and smaller than the wide area networks. Right? Special devices and cables are used for LAN connection. Bank networks of institutions with branches, university networks with branches can be cited as example. Right? So that is MAN. Then we will come to the large type of network, that is WAN, wide area network. Wide area network. Networks designed to cover a large geographical area such as state, region, country as known as wide area. So this type of networks WAN covered a huge geographical area, maybe whole country, maybe out of the country. Right, so it's maybe connecting one network from USA and one network from the Sri Lanka, another one from the Australia. Right? A WAN is typically used to connect two or more LANs or MANs that are located far apart. Special devices, cables, and technologies such as telephone networks, network services providers. Right? Satellites also used to provide communication connectivity. The best example for this is the internet. So several LANs available maybe in several countries are interconnected. So large geographical area is covered, right? A large geographical area is covered. This kind of network we called as the WAN. Okay, so again, there's a video. So let's watch this one. So you will further understand what I explained up to now.
Hello everyone. In this video, we're going to talk about the different network types. And these network types depend on how large they are and how much of an area they cover geographically. Now, most people who have a basic knowledge of networking are familiar with terms such as LAN and WAN. But in addition to those, there are a few more network types that a lot of people are not familiar with. So that's what we're going to talk about in this video. So let's first talk about a PAN. PAN stands for Personal Area Network. Now this is a type of network that is used on a personal level. It's a small network that is used for connecting devices such as smartphones, tablets, and laptops. And they connect to each other by using wireless technologies such as Bluetooth, infrared, and near-field communication, or NFC. But they can also connect by using a wired connection, such as a USB cable. PANs are generally used for transferring small files, such as music, photos, calendar appointments, and so on. And the next type of network is a LAN. Now LAN stands for Local Area Network. A local area network is a group of devices such as computers, servers, switches, and printers which are located in the same building, such as in an office or in a home. In other words, in close proximity to each other. The most common type of LAN is an Ethernet LAN, where two or more computers are connected to Ethernet cables using a switch. Now, a WLAN, or Wireless Local Area Network, is a local area network that uses wireless communication instead of wired communication. A wireless LAN is defined as having at least two devices that use wireless communication to form a local area network. A wireless LAN will typically have a Wi-Fi router or a wireless access point for wireless devices such as laptops, tablets, wireless desktops, and smartphones to communicate. So in simple terms, a wireless LAN is a LAN but without using cables. And the next network type is a CAN. Now CAN stands for Campus Area Network. A CAN is a network that joins two or more LANs together within a limited area. So for example, a CAN could be a university that has multiple buildings in the same general area that are connected to each other to form a larger network. So these buildings could be different departments on a university's property, with each building having their own LAN in their department, and then the buildings are connected to form a campus area network. And the next network type is a MAN. MAN stands for Metropolitan Area Network. Now this is a larger network than a CAN. It's a network that spans over several buildings in a city or town. MANs are typically connected using a high-speed connection such as fiber optic cable. It's a high-speed network that gives the ability for sharing data and resources within a city. And the next one is a SAN, or Storage Area Network. Now, a SAN is a special high-speed network that stores and provides access to large amounts of data. Basically, what a SAN is that it's a dedicated network that's used for data storage. This network consists of multiple disk arrays, switches, and servers. One of the main reasons for using a SAN is because SANs are not affected by network traffic, such as bottlenecks that can happen in a local area network. And that's because SANs aren't really a part of a local area network. It's partitioned off. It's a network all by itself. And then finally, there's the Wide Area Network, or WAN. A WAN is the largest type of network. A WAN includes multiple LANs, CANs, and MANs. It's a network that spans over a large geographical area, such as a country, continent, or even the entire globe. A good example of a wide area network is the Internet.
That's all about the networking part, right? So we have another thing to discuss. So before I move to that part, so anybody can ask question if you have any doubt regarding the things what we have discussed. Okay, so if not, so we can move to the other part. Okay, so this is the next part we need to discuss, right? So internet architecture and the services. So we will discuss this part. So I'm going to take a small break. So after the break, we are going to discuss about this internet activities. Okay, so let's start again. So internet architecture and the services, right? So let's first talk about the architecture, then the internet services, right? What is the internet? What do you mean by the internet? The internet is a collection of computer networks around the world. So all the computers in the world have been interconnected. So we talk about the mesh topology, right? So like in that way, they all are interconnected. So this kind of network we called as the internet. The internet is the fastest way to communicate information with the world community, right? With the use of internet, today the whole world has become a global village. The internet has no single owner, which fulfills a vast mission. And currently, a non-profit organization called the Internet Society deals with the policies and protocols that maintain the operation of the internet. So, no single owner for this internet, right? So, organization called the Internet Society produce the protocols mean the standard, right? Rules we need to work with, not like rules mean the police rules, right? So the standards, the computer standards, what you need to follow when we are connecting with the internet. So that those things that what we are going to learn today. So there are many then first internet components. So many parts are needed to connect with the internet. A server, client machine. So something called World Wide Web, WWW, web browser, IP addresses, domain name, URL. So these are some things we need to connect with the internet, right? First, let's talk about the server. So already we have discussed in several places. A server is a computer which with special software capable receiving requests for information from client and sending that information to the respective client. So it's a kind of computer, desktop computer, which has special features. It's not like very traditional desktop computer. So server computers are very powerful, right? Very high capacity, very high speed, and many other extra features. So it needs special operating system, special different kind of softwares to operate. So it's not like normal desktop computer, right? So different servers has different tasks. We are maintaining in the world different kind of servers for different purposes, right? So as an example, there are something called mail server. In any office, it is having, if you have official email, not like Gmail and all, right? So if you have any official email in your office, it's have a, if you, your organization should have a mail server to handle those official emails. Even the Google company is having a very large, complicated mail server to handle Gmail. If you are producing your own emails, right? So you are having mail server, web server. If you maintaining a website or websites, so you need a web server to save those web pages, right? A web server. Then there are something called the DNS server. DNS server provides a special facility converting URL to IP addresses. So we are going to discuss this one, right? Converting URLs to IP addresses. So likewise, FTP servers, likewise, there are many different type of servers for different purposes. Then the next one is the client. This is server. These are clients. These are clients. A client computer that has a software to send requests to get the information from a server. So this client's computer, right? So all the client devices sending messages to server. Suppose this is a web server, right? This is a web server. So this computer wants to see the website. So it's sending a website. It's sending a request to this server. So I want to see the website of University of Moscow. So it is coming here. So when this server identify the request, okay, this computer need to see the website of University of Moscow. Then he send the message to showing the University of Moscow website to this computer, right? So this is client computers. So when a person send an email, the email app on the phones acts as a client. So it send the request to the mail server, sending, okay, I want to send this message, or I want to this particular person, mail server. So clients get the services of the servers. The World Wide Web, normally we call this as the WWW. So worldwide is something, again, something confusing by the students. Right? So many people think www is the internet. No. www is not the entire internet. www is a part of the internet. If you divide the internet into different parts, right? It has different parts. Websites, right? Emails, file transfers. So many parts are there. So www is one of the part of the internet. That is the website part. There are many other parts, right? Remember, www is not the entire internet. www is a collection of websites or web pages stored in the web servers. These websites contain text, pages, digital images, audio, video, etc. Users can access the content of these websites over the internet from anywhere in the world using devices such as computers, laptops, or mobile phones. WW uses HTTP, Hypertext Transfer Protocol. That is the rule. To access the websites, your devices should follow this rule, HTTP rule. Even the mobile phone, even your laptop, desktop, all the devices should, if those devices follow this rule, HTTP, Hypertext Transfer Protocol, then only you can go for the websites. This is the protocol. This is the rule you need to follow. Your device should follow to access the website. HTTP. Right? So there are different this kind of rules. So web browsers, there are many type of web browsers we are using in these days, right? So my Chrome for my Microsoft Mozilla Firefox, Chrome, Opera. Now Internet Explorer is not there right now. So in the Microsoft company has introduced a new browser called it as the Edge. Now Internet Explorer is not there, and Apple Safari. All these web browsers are needed to connect with the internet, especially to see the web pages. So through the web browsers, we can type the URL of the particular website what we need. Then web browser convert that into a different coding and send the message to the particular web server and get the required website on the web browser.
Oh,
Someone's mic is on.
Convenience. Oh,
Please
sir.
switch off your mic. Someone's
Oh,
mic is.
sir.
Sulfika, your mic is on.
Okay.
Please switch off your mic. Protocols. Protocols mean the rules. When you access the internet, what are the rules you need to follow? The whole internet is governed by the protocol. The whole internet is governed by the protocol. Different rules. A protocol is a set of rules that operate within the computer networks, right? Some of the rules are below. So these are the rules which your network, which your computers are following to connect with the internet, right? So HTTP, that means the Hypertext Transfer Protocol. So you need for the document sharing. TCP/IP, Transmission Control Protocol, Internet Protocol, controlling the exchange of addresses. FTP, File Transfer Protocol, file sharing. SMTP, Simple Mail Transfer Protocol, mail sharing. When you send the mail, so your computer should have this, should follow these rules. When you transfer files, your computer should follow these rules. ICMP, Internet Control Message Protocol, message notification and message control in case of errors. So these are terms. There are many. Some of the protocols which need to follow by your computers to for different tasks, right? So one thing you need to identify, IP addresses, Internet Protocol Address, right? So any computer which is connected with the internet should have an IP address. If your devices is not having an IP address, your devices cannot connected with the internet. Why this IP address is needed for the devices? Because uh, millions of computers are connected to the internet. Each device should be able to identify uniquely. Suppose the CNN server, the website is hosted somewhere in US, right? So that server which is hosted the CNN website, right? Getting millions of requests to show the website, millions per request per second. So then how that server served if that server cannot identify who has sent the request? If that millions of requests should be able to identify separately by that particular server. Otherwise, he cannot, though the request came to the server, he cannot send the answer for that particular computer because that server cannot identify the particular computer who has sent the request. For that, each computer which is connected with the internet should have an IP address to identify it as uniquely. Right? Sometimes the IP addresses given to the computer permanently, especially your office computers. It was given the IP addresses permanently or sometimes temporarily. Suppose in even not only the computers, even suppose at the home you are connecting to the internet with your mobile phone, desktop, laptop, everything. So by permanently you haven't given the IP addresses for these devices, but you are connecting to the internet through an internet provider, right? Maybe different names, right? So maybe Dialog, Mobitel, SLT, who else, right? So when you are connecting to the internet through these service provider, right? So when at the moment when your device is connecting to the internet, is trying to connect with the internet, that service provider temporarily assign not the service provider, they are servers providing a temporary IP address to your devices for the moment. Then your device is assigned the temporary IP address. Okay. Now your device can connect to the internet. Right. So then after some times you disconnect the internet. Right. You disconnect the internet. Then after another time, you are again connecting to the internet. So then your device, same device is getting another internet, not the same, another IP address, not the same IP address which you got earlier. Anyhow, you need the IP address to identify your device uniquely within the internet. Therefore, your devices may have permanent IP addresses assigned or temporary assigned IP addresses. Anyhow, when you are connecting, the most important thing what you remember is when you are connecting to the internet, your device, when you are connecting, your devices are connecting to the internet, you need an IP addresses to identify. Your device needed to unique IP address to identify uniquely within the internet. Normally, IP addresses are given with numbers. We know that the computers can identify numbers, not the words. Even we type the words, the computer, we typing, we can see the words, but computer will recognize, identify those words as numbers. So in the computer, we know we are, as a practice, we say 1 zeros. That is how computers will identify everything what we type, even the diagram, even the pictures. Right? So 1 0 type. So we take if byte, 1 byte, right? So 8 numbers. So normally this is the way of typing an IP address. Is that it has 4 parts, right? It has 4 parts. So we are normally telling this 172.16.254.1. So one part is having 8 bytes, 8 bits. Altogether 32 bits. One IP address has 32 bits. This one part can vary from 0 to 255. 0 to 255. This is again 0 to 255. So the numbers which we can have in each part from either 0 or 255. No numbers below 0, minus, no. No numbers above the 255, 256, 257, no. Up to 255, right? So this is 254, 16, 172. So either your computer has a permanent IP address or temporary IP address when your devices are connecting to the internet, right? Then the domain name. Domain name. A domain name is used to locate the identify computers on the internet. An IP address is a set of numbers is assigned to each computer connected to the internet for a unique identification. However, people find it difficult to remember set of numbers. So domain name. So normally in the browser, what we are typing www.google.com, www.cnn.com, www. What else? youtube.com, right? So we type some names. But normally those are numbers, right? So as an example, right, this 157.166.226.25. If you read this, even it is very difficult to remember, right? So people, the humans cannot remember these numbers heavily, but they can remember this wording. Everyone knows everyone can remember www.cnn.com, right? www.cnn.com. So this is the, rather than if you rather than typing this cnn.com in your browser, type this number 157.166.226.25. You will get the, let's see whether, so you can try, right? So whether you can get the same site, right? So rather than entering these numbers, you can enter, so rather than entering this wording, you can enter this number and get the same site. When a domain name is entered into a web browser, a DNS server translates the domain name into the IP addresses. So you type in your computer, you type the URL. So your computer is connected to one of the DNS server, domain name server. DNS means domain name server, right? So DNS, so it try to understand what this, where this particular website is having, right? So this one. So if this DNS server knows exactly the place he sent to the particular server. If this particular DNS server is not knowing exactly where this particular website is available, so he send the request to the nearby server asking whether do you know this particular web address. So this particular DNS server is converting this particular name into number. Okay, he knows the exactly address. He's sending, okay, this is the IP address of this particular website is the IP address of the server which this particular address is available. Then when he get this number, he send in to the computer, your laptop. Okay, this is the server, you need to send the request. Then your computer send in directly to the CNN website, web server, asking, okay, send the website to me. This is how this DNS servers will convert these names into the IP addresses. These names into the IP addresses. Domain name has different parts, right? Domain name has different parts, right? Sometimes if you take this one, hope you have seen this, right? www.edupub.gov.lk, right? www.edupub.gov.lk. Now, what is lk.lk? That is Lanka. That is related to Sri Lanka. So this is the problem the problem had. So the incident what discussed in last month and that hacker problem, right? So people who have responsible this one have not realized difference between this country name and the .com. If it is a government thing, right? So normally it is having this country name if it is a government site, right? .lk, .uk, .au, .uk means United Kingdom, British. AU means the Australia. IND means India, right? IN. So two letters represent the country, government site. Now, this gov.lk, gov means government site. Gov.lk means government of Sri Lanka. Gov.au means government of Australia. Gov means the government. Sometimes you can see .com. That means that is a commercial site. Anybody, even you can have .com. That is a commercial. Sometimes you can see .org. Non-revenue organization, NGO. .gov means the government. Sometimes you can see .edu. It's an education site. Anything related to the education institution. .net. It's related to some network party. Right? These are the top main domains. .lk, .in, .au, Australia, UK, United Kingdom, US, America. You have a better understanding how this URL, what this URL represent. Then what when if you know these things, at least something. So by looking at the URL, you can identify whether this is a government site or a commercial site, education site or whatever. Sometimes you can say ac.lk, cmba.lib.ac.lk. AC means academic, right? ac.academic. Most probably the universities, higher education institutions. So there's a small video again, right? So explaining how these domains work, right? Domain server works. Let's watch this one.
In the world of networking, computers don't go by names like humans do. They go by numbers. Because that's how computers and other similar devices talk and identify with each other over a network, which is by using numbers such as IP addresses. Humans, on the other hand, are accustomed to using names instead of numbers. Whether it's talking directly to another person or identifying a country, place, or thing, humans identify with names instead of numbers. So in order to bridge the communication gap between computers and humans and make the communication a lot easier, networking engineers developed DNS. And DNS stands for Domain Name System. And DNS resolves names to numbers. To be more specific, it resolves domain names to IP addresses. So if you type in a web address in your web browser, DNS will resolve the name to a number, because the only thing computers know are numbers. So for example, if you wanted to go to a certain website, you would open up your web browser and type in the domain name of that website. So for example, let's use yahoo.com. Now technically, you really don't have to type in yahoo.com to retrieve the Yahoo web page. You can just type in the IP address instead if you already knew what the IP address was. But since we are not accustomed to memorizing and dealing with numbers, especially when there are millions of websites on the internet, we can just type in the domain name instead and let DNS convert it to an IP address for us. So back to our example, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will resolve that domain name to the IP address of the Yahoo website. And once that is done, then your computer is able to communicate with the Yahoo web server and retrieve the web page. So DNS basically works like a phone book. When you want to find a number, you don't look up the number first. You look up the name first, then it will give you the number. So to break this down into further detail, let's examine the steps that DNS takes. So when you type in yahoo.com in your web browser, And if your web browser or operating system can't find the IP address in its own cache memory, it will send a query to the next level to what is called the resolver server. The resolver server is basically your ISP or Internet Service Provider. So when the resolver receives the query, it will check its own cache memory to find an IP address for yahoo.com, and if it can't find it, it will send the query to the next level, which is the root server. The root servers are the top or the root of a DNS hierarchy. There are 13 sets of these root servers, and they are strategically placed around the world, and they are operated by 12 different organizations. And each set of these root servers has their own unique IP address. So when the root server receives the query for the IP address for yahoo.com, the root server is not going to know what the IP address is. But the root server does know where to send the resolver to help it find the IP address. So the root server will direct the resolver to the TLD or top-level domain server for the .com domain. So the resolver will now ask the TLD server for the IP address for yahoo.com. The top-level domain server stores the address information for top-level domains such as .com, .net, .org, and so on. This particular TLD server manages the .com domain, which yahoo.com is a part of. So when a TLD server receives the query for the IP address for yahoo.com, the TLD server is not going to know what the IP address is for yahoo.com. So the TLD will direct the resolver to the next and final level, which are the authoritative name servers. So once again, the resolver will now ask the authoritative name server for the IP address for yahoo.com. The authoritative name server or servers are responsible for knowing everything about the domain, which includes the IP address. They are the final authority. So when the authoritative name server receives the query from the resolver, the name server will respond with the IP address for yahoo.com. And finally, the resolver will tell your computer the IP address for yahoo.com, and then your computer can now retrieve the Yahoo web page. It's important to note that once the resolver receives the IP address, it will store it in its cache memory in case it receives another query for yahoo.com, so it doesn't have to go through all those steps again.
Right. Let's see how this URL, what are the content of a URL is having, right? So normally we can see, suppose this URL, it says http www.edupub.gov.lk ebooks English ICT.pdf. So this kind of things you may have seen when you are typing or getting something from the internet, right? So normally we call this as a web address, URL or Uniform Resource Locator, URL. So what this has, this final part, this is the name of the file what we are referring, right? This is the name of the file what we are referring, right? It can be a PDF, it can be a .com, sorry, it can be a Word or something, image or something. And this is the part where this resource is located in the server. This is not the part for the server. This is the part for the server. In that particular server, this is the location, right? So this is the domain name. This is the edupub is the domain name. So we know that gov means the government, .lk means the Lanka, Sri Lanka. So www. So this is, we are referring the websites. We are referring the website. That is why we have put the www. And this particular, to get this particular service, it should follow this protocol, HTTP, Hypertext Transfer Protocol. To get this particular website, to get this particular document, so the computer should follow this rule. These are the things explained by a URL. Okay. So Uniform Resource Locator, URL, is the method used to uniquely identify the various resources contained in the World Wide Web. It is also called as the web address. A URL consists of several parts, including a protocol and a domain name. A URL describes how and where a resource can be accessed by a web browser. Right? So when we type all these things into the web browser, so web browser convert these things to numbers and get the correct resources what we are requesting. Right? How the internet work? How the internet works? When accessing a uniform resource locator, when typing a URL for a browser to view the website, normally we type the URLs in the browser to get the website, right? It must first translate the request from a readable written address to an IP address. So we are typing the words www.google.com something, right? So those things should be converted into numbers to identify the address where this particular website is available. This translation is done by the domain system server, DNS, right? Domain name system. So when we type the URL, right? When we type the URL, so it is directing to the DNS server. So DNS server is looking for the IP address which this particular resource is available. In order to connect website, after entering its address into the web browser, what actually happened is that the request is sent to the DNS server to translate the entered website address to the correct IP address. So you type here URL. So it is directed through your operating system to the DNS server. Then DNS server converts this URL into the IP address. Then your computer is having the number. You type letters, but computer web browser identify the number where the request has to be sent. Right? Then your browser send the HTTP to get command to the web server. Now he has identified where the web server is located. He has sent you a message with the converting to the numbers to the web server. Now web server identified, okay, this particular computer has sent me a request to request in the website, and he's sending the website as the HTML, and your computer is converting, your browser is converting that HTML page into a web page having the words and the images, right? So it builds a real connection to the respective website from IP address. When the request arrives at the web server finds the particular file and then send the file to the client's browser. This is a behind the scene of process. So this is how we connect with the internet. Right, let's see. So again, this particular video explained very simply how we are getting the internet. Right, so very interesting video which I found. So let's watch this one as well.
Where does the internet come from?
Where does the internet come from?
Not sure? Okay, let's start with the basics. The internet is a global network of interconnected computers used to deliver that vast collection of digital pages we call the World Wide Web. They're not the same thing. It's actually an enormous system of cables, real physical cables, traveling all around the world, connecting our devices to the servers that store the pages we want to view. How does it work? First, your device needs to connect to your internet service provider's network. Congratulations, you're now part of the internet. By entering the address of the website you want to visit, you send an electronic request for information over your phone line or cable to your ISP. The ISP sends the request to a server further up the chain, a domain name server or DNS, which acts as a kind of directory. The DNS looks for a match for the address you've typed in. When it finds it, the request is sent to the server hosting that website. That server could be in a different country, so the request needs to travel along cables both under the ground and under the sea to reach its destination. Yep, it really does go under the sea. These subsea fiber optic cables literally connect the world, linking continent to continent, with the exception of Antarctica. 95% of international digital traffic travels this way. Just think, most of your tweets and emails have been underwater. Running under the seabed, these thousands of kilometers of fiber optic cable are known as the internet's backbone. Without them, the global internet just wouldn't work. Amazingly, they're only as thick as a garden hose, making them prone to the occasional shark bite. So, if your internet's slow, blame a hungry shark. It's never a big problem though. The cable network's so vast, the request simply reroutes. Contrary to popular belief, the internet is never down. The request finally reaches the data center housing the server where the website lives. The server sends the requested information back across the network, broken down into chunks of data called packets, which your device puts back together like a jigsaw to form the web page you see on your screen. And all this happens in the blink of an eye, all over the world, millions of times per second.
Okay, hope that video explained very simply how we are connecting with the internet and how the things we are getting through the internet. So as it says, so it's lot of cabling, right? So under the sea. So if something happens to these cabling, so whole world in a mess. So during the wartime, this Iran and the US, right? So there is a high risk of damaging to this cabling, underground, undersea cabling, right? If one country done that, so all these communication will be vulnerable, right? So underground, undersea cabling. Okay, this part, next part is services of the internet, right? So I will keep this part. So there are several services, right? So I will keep this for the next time, next day. So I would like to give you the question for this week, right? Right. This is the question for today, right? So assignment number 3, briefly describe the benefits of computer networking to your library, right? Briefly compare and explain the function of the switch and the router, right? And I can see, right? So many people getting the help of these AI tools, right? So they will put the question and give me the very perfect answers. Definitely, I can identify who has written genuinely and who has written using the AI. Right? So you can remember, you can complete these assignments by using AI because so you have the tools, you are at home, so you can use the resources. But it's definitely if this is a physical class, I'm going to have the question face to face. I'm not going to give you I'm not going to give you the answer in the paper. But remember, so you can do for the UI assignment, right? So you can get the marks as well. But when the question is given at the UI examination, right? If you have no idea in your mind, so what is you are going to write? That is why you will not get marks for your exams. That has happened to many students, right? So they are doing, so I'm not telling you that don't use the AI, but don't directly apply the answers given by the AI. You think whether this answer is matching for the required answer. Sorry, the question. Some people just giving the entire thing given by the AI. Some parts are not necessary. Very lengthy question, very lengthy answers for the questions. Right. So anyway, so this is the question, and I will put the email address in the chat. Now you can start answering. Right. Hope you need to send me the email before 12 o'clock. Right. So it's almost there are 40 minutes time to answer. So this is a small question. Right. So please start answering and send the question. So send the answers. So hope that you are not going to send me the AI generated answers. Right. Start writing your answers.